on page 15 of the notes, we are going to go from scientific notation to standard form. And as it says up here, it's actually even easier because it tells you how many times to move the decimal and then which direction. So remember that positive exponent means we're going to move right, and a negative one means we're going to move left. So a positive should be a big number, and a negative should be a very small decimal. Now I'll show you how you can do this without having to move the decimal if you want. So you can always move the decimal and make your loops, or there's another way we can do this. So our first one, 6.38 times 10 to the positive third. So positive means we move it right 1, 2, 3, so we need to add an extra 0, 6380. I do want you to put the commas in, so remember you start at the back and count to the left 3, so 6,380. If you don't want to do the loops, what you can do is this, just take the decimal out, but realize you're counting 1, 2, so we need 3 places, so any extra needs to be a 0. Okay, so here's 1, 2, then our third one needs to be a 0. So if I do that right away for this one, 2085, so 1, 2, 3, I need 2 more, so I need 2 zeros. Right. Again, if you would rather do 1, 2, 3, 4, 5, and then see the 2 zeros, that's fine. Count back 3, 208,500. This one we only move 1 time, so 98 and 2/10, 98.2. This one I'm going to do it again without the loops first, so 5, 3, 8, 8. So 1, 2, 3, and I need 6, so I need 3 zeros, 1, 2, 3. Count backwards, 5,388,000. This one we're only moving right twice, so 821. So that takes up all the positive ones. So positive ones, again, you should have big numbers. You should not have anything less than 1. With your negative exponents, you're going to move to the left. So same thing, you can move this 5 times, 1, 2, 3, 4, 5, and that's where your decimal goes. So you're going to have 0 decimal. I do want you to put a 0 in the front, and then there are 4 zeros, and then 525. Kind of the nice thing about moving left is you will always have 1 number and then the rest zeros. All right, so if you are doing this without having to write the loops in, you can say there's 1 number that I have to move, and then there's got to be 4 more to get to my 5. So there's 4 zeros and then 525. This one we just move once, so 0.7932. Okay, so this one we're supposed to move 7 times. So I don't want to have to make 7 loops. So I knew I move it once, and then we need 6 zeros. Now that doesn't count that first one. So now I need 6 zeros. And then I can finally put the 162. All right, so this took up 1 of these, which means there's 6 left. Same thing, I don't want to make 8 loops. So I know that this will take away 1 of them, so I need 8 zeros, not counting that one in front of the decimal point. 8 zeros and then 2, 4. My last one, I only moved twice, so sometimes it's easier just to do that. Or you see we move it once, so then we need 1 more 0, 6018. You can always go check by going in the reverse order. If I move it twice, make sure I would end up with that. Here we want to compare our numbers. Some people will teach you or just say that you need to write the numbers out completely, change them into standard form, but you actually don't. a bigger exponent will always equal a bigger number. A bigger exponent will always be a bigger number, or you could say a smaller exponent is the smaller number, either way. Now, if you have the exact same exponent, which we don't here, but if you did, then you would just go by whatever the number is. So if we just look, if this one also would have been a 3, this one would be greater because 7's bigger than 3. All right, but for now, we just need to compare the exponents, a 3 and a 5. A 5 is bigger, so it would be like that. Okay, and the reason, again, this one we would move 3 times, so 7,420. This one we would move 5 times, so it would look like that. So if you want to write it out in standard form, you're more than welcome to, but hopefully you don't need to. 7 is way bigger than 4, so that's going to be a greater than sign. Negatives are a little bit tricky. -2 is actually bigger than -3. Okay, -2 is actually bigger than -3, so this number would be greater than. And again, if you're not sure, if we move it twice, we would have 1 0 there. This one we have to move 3 times, so there's 2 zeros. So this number is a little bit bigger than this number. For 28, -6 is way smaller than -1, so that's a less than sign. Story problems are usually kind of scary, but again, all of it's asking us to do is to write it in scientific notation. So if you want to do your loops, you can do that. Otherwise, the decimal needs to move from there all the way to there. So you need to count all of those digits. There are 15 of them. So we would have 2 times 10 to the -15. This last one asks us 2 questions. Which planet is closer and by how many miles? We have to give our answer in scientific notation. So from the Earth to the Sun is 9.3 times 10 to the 7. Mars to the Sun is 2.28 times 10 to the 8. This one is smaller. The 7 is smaller than the 8. So the Earth is closer. So that answers your first question. By how many miles, and you need to put it in scientific notation. We don't know how to subtract scientific notation yet, so you're going to have to change them to standard form. So 2 to 8, so that took up 2 of mine, and I need 6 zeros. Minus this one, 9, 3, so I moved it once, so that means I need 6 more zeros. All right, so that you're going to want to type into your calculator. All right, and gives you that huge number. Some of your calculators might actually put that in scientific notation for you. But it would look like that. Okay, some of you might realize, oh, they have the same amount of zeros, so you could just do 228 minus 93. But you have to remember those zeros are still in there. So they want it in scientific notation though. So 1.35 times 10, so I moved it here, 1, 2, 3, 4, 5, 6, 7, 8. 1.35 times 10 to the 8.